Recall that a vector is a quantity that has magnitude and direction. For example, displacement, velocity, acceleration, and force are all vectors. In one-dimensional or straight-line motion, the direction of a vector can be given simply by a plus or minus sign. Motion that is forward to the right or upward is usually considered to be positive, and motion that is backward to the left or downward is usually considered to be negative. In two dimensions, a vector describes motion in two perpendicular directions, such as vertical and horizontal. For vertical and horizontal motion, each vector is made up of vertical and horizontal components. In one-dimensional problem, one of the components simply has a value of 0. For two-dimensional vectors, we work with vectors by using a frame of reference such as a coordinate system. Just as with one-dimensional vectors, we graphically represent vectors with an arrow having a length proportional to the vector's magnitude and pointing in the direction that the vector points. This figure shows a graphical representation of a vector, the total displacement for a person walking in a city. The person first walks 9 blocks east and then 5 blocks north. Her total displacement does not match her path to her final destination. The displacement simply connects her starting point with her ending point using a straight line, which is the shortest distance. We use the notation that a boldface symbol such as D stands for a vector. Its magnitude is represented by the symbol in italics D, and its direction is given by an angle represented by the symbol. Note that her displacement would be the same if she had begun by first walking 5 blocks north and then walking 9 blocks east. The head-to-tail method is a graphical way to add vectors. The tail of the vector is the starting point of the vector, and the head or tip of a vector is the pointed end of the arrow. The following steps describe how to use the head-to-tail method for graphical vector addition. Let the x-axis represent the east-west direction. Using a ruler and protractor, draw an arrow to represent the first vector, 9 blocks to the east as shown in the figure. Let the y-axis represent the north-south direction. Draw an arrow to represent the second vector, 5 blocks to the north. Place the tail of the second vector at the head of the first vector as shown. If there are more than 2 vectors, continue to add the vectors head to tail as described in step 2. In this example, we have only 2 vectors, so we have finished placing the arrows tip to tail. Draw an arrow from the tail of the first vector to the head of the last vector, as shown. This is the resultant, or the sum of the vectors. To find the magnitude of the resultant, measure its length with a ruler. When we deal with vectors analytically in the next section, the magnitude will be calculated by using the Pythagorean theorem. To find the direction of the resultant, use a protractor to measure the angle it makes with the reference direction, in this case the x-axis. When we deal with vectors analytically in the next section, the direction will be calculated by using trigonometry to find the angle. Vector subtraction is done in the same way as vector addition with one small change. We add the first vector to the negative of the vector that needs to be subtracted. A negative vector has the same magnitude as the original vector but points in the opposite direction, as shown in the figure. Subtracting the vector b from vector a, which is written as a minus b, is the same as a plus negative b. Since it does not matter in what order vectors are added, a minus b is also equal to negative b plus a. This is true for scalars as well as vectors.